Hi, I'm Amar and I'm an AI solutions engineer here at Skyfire. And today I'm going to show you an agent that discovers, accesses, and pays for tools in order to complete a task it's been given. This is a general purpose agent that I wrote with the AWS Strands agent framework in Python, and it's entirely prompt based. A general purpose agent is one that can discover new tools, knows how to install them, and knows how to use them. Knowing how to use tools is typically done via descriptions in the OpenAPI specs or tool descriptions and resources in MCP servers. In this demo, I'll be playing the role of a financial analyst who's been tasked with preparing a report on pickup truck sales in the US for 2024. Instead of manually searching for that data, creating accounts, buying data sets, and finally preparing the report itself, I'll be using my general purpose agent that is powered by Skyfire's KYA Pay protocol to automate this entire workflow for me. This would mean my employer no longer needs to make bespoke financial deals for premium data, and instead my agent can buy the specific data I need when I need it for my reports. Here's an overview of the main steps that the agent will be performing. So first, we're going to find a seller of the premium financial data. That's going to be done by searching through the Skyfire directory of services that we have. Next, we're going to install the seller's MCP server. We're going to connect to the seller's MCP server. And then in order to use its tool, we're going to need to sign in and authorize with the server. We're going to find the data set we need from the service, purchase the data set, and this is also where Skyfire's KYA Pay protocol comes in to create a payment token equivalent to the price of the data set that will be sent in the request. It will be sent in the header of the request when fetching the data set. We're going to download the data set and then analyze it and then upload it to Google Sheets for review. So these are the steps to look out for, and we're gonna take a look at the agent itself. So this demo uses a simple general purpose agent, and the agent has been initialized with a few tools to discover, install, and use tools from the OpenAPI specs and remote MCP servers. The agent doesn't have a front end, so what you'll be seeing here is the agent's log that it outputs as it runs. So the agent begins by searching for a seller of the dataset in the Skyfire service directory by using the Find Seller tool. This is a tool from the Skyfire MCP server, which the agent has access to on initialization. This could have been any directory of services, or the agent could have queried multiple directories, but here we're searching the Skyfire directory. So it discovered CarbonArc, who offers its services through an MCP server. So the agent then installs the MCP server and lists the available tools with their inputs and outputs that from that CarbonArc server. After it's listed the tools, it's then going to plan a sequence of tool calls in order to acquire the data set that we've tasked it with retrieving. So this is it planning right here. But to actually call CarbonArc's tools, the agent first needs to create an account as it's recognized in this first step. And the agent has seen from the create account and login tool call that CarbonArc requires a KYA token from Skyfire plus a password. So the agent will first call the create KYA token tool call to get a KYA token from Skyfire. And that's what this is right here. Next, we're going to decode the token so we can inspect the identity information held within. What we can see is that the Skyfire KYA token encodes the human principal's identity, which is the person behind the agent. So we can see here in this bid claim that the Skyfire email is my Skyfire email, amar@skyfire.xyz, because I am the principal behind the agent. So this verified email address is the only identity information enclosed, but the seller could have required additional info such as a name, address, phone number, EIN, or any number of other identity fields. CarbonArc had no such identity requirements, so a verified email was sufficient to use their services. So that's great. The agent generated the KYA token with Skyfire, and then also calls the tool create account and login with the KYA token, as well as a password, which we can see right down here. So CarbonArc's create account and login tool in turn presents the KYA token and password to its CIAM. CIAMs manage user accounts and authorization for applications. The CIAM will extract the human principals information and create an account in the CIAM and or log in the agent if the account has already existed. So what we'll get back from this create account and login call is a access token that the agent can use for all further interactions to have authorized access to CarbonArc's tools and endpoints. The agent can subsequently share the password with its human principal so that the human can also log in to check the account in the future. So with this access token, the agent can now call the other tools from CarbonArc and search for the data set. So it's found a relevant one, the 2024 U.S. automobile data, and next it's going to retrieve the pricing right here. It's going to get pricing, and then it's just 0.002, which is well under our budget of 0.005. So it's going to proceed with creating paying for this data. So the agent then uses Skyfire again to create a payment token for the transaction for the amount 0.002, the price of the data set. And this is the corresponding token created. And we can see the amount enclosed in the token, 0.002. So that's great. With the pay token created, the agent calls the download dataset tool, as seen here, with the payment token enclosed. It receives a link to the purchase CSV file right here, and the dataset contains the monthly pickup truck sales figures for 2024 in the US. The seller can then charge that enclosed payment token right here and move money from my buyer agent to the seller CarbonArc's account, with Skyfire settling that payment. So now we have the CSV data. So we're gonna retrieve the file content and get the actual all the rows of the file, and then the agent's going to perform analysis on the downloaded dataset and push the results to a Google Sheet using the upload CSV tool to create a presentation for us to review. And that's what's happening here. And we can see from the results, here is the spreadsheet I was mentioning. So both of these last two tool calls, retrieve file content and upload CSV, are part of a reporting MCP server, which is just a simple MCP server for routine data extraction and visualization that the agent has also been initialized with, similar to Skyfire's MCP server. The export and presentation step was outside the scope of Skyfire's scope, but it shows the end-to-end data analysis flow that the agent is capable of. And so let's take a look at the spreadsheet that was generated. Here we can see all the truck sales on the left, and then a diagram or a chart on the right. So that's the output of all the work that our agent did. So let's just do a quick recap of everything we've seen. So the agent searched Skyfire's directory to use, using the Skyfire MCP server find seller's tool, found the CarbonArc service it needed and connected to it, created the KYA tokens necessary for the identity information, created an account and logged into CarbonArc using that KYA token and a password, searched for the dataset it needed, purchased the dataset using a KYA pay token in this case, and then downloaded it and analyzed the dataset, and then created a Google Sheet for us to review. And then, as a reminder, CarbonArc can then charge the pay token the agent delivered at any time and complete the transaction, receiving the money for the data it delivered. With this, the agent has completed the end-to-end flow it set out to do. And if you want, you can fork this repo today and get started building agents that can pay for services on Skyfire. Please feel free to reach out to us with any questions you may have about the code or the platform. Thanks so much for listening.